I welcome all of you on the platform of YourPedia Education, and my this particular interaction with Professor Suman Chakraborty is very interesting and very relevant to all of you. We are actually interacting with the luminaries and professors who recently participated in first ever R&D fair held in IIT Delhi in October on October 14th and 15th, 2022. One of the projects of Professor Suman Chakraborty was Covirap for rapid detection of COVID. We know 2 years back we were struck by COVID. That is a pandemic we were struck with. And then, people like Professor Suman took it as a challenge to come out with the detection kits and all. And today we have Covirap. And it is really very good invention. In fact, Professor Suman is credited with a lot of inventions. He's a researcher par excellence. He's not only professor and academician and researcher. He's entrepreneur also. He has his own startup companies in IIT Kharagpur, and he's in administration also. He's dean R&D. Earlier he was heading School of Medicine in IIT Kharagpur. So there are so many research domains in which Professor Suman is working: microfluidic infection diseases detection domain, molecular diagnostics, and then chip technology, rural healthcare, and there are some of the research areas which I mentioned. It was a 2 hours marathon session with Professor Suman. So many things to be discussed, but I still believe that within 2 hours also it is difficult to summarize the research work of pioneers and researchers like Professor Suman. So I was really very happy to interact with Professor Suman. It was a total delight was mine, and it was very informative and interesting interaction. So I request you to spare time and listen to what Professor Suman is to offer. So let's go and listen to the entire discussion. So Professor Suman, welcome on YourPedia Education, and thanks a lot for your time, sir.
Yeah, thanks a lot, and it's a great honor to be there in this platform where I see lots of luminaries in academic field and beyond. They have been there previously. Thank you very much for inviting me.
Yes, Professor Suman, you are an authority on many fields of research and specializations. To mention a few, you have done marvelous work in microfluids and on infectious disease detection, molecular diagnostic tests you have created, chip technology, rural healthcare. These are some of the research areas in which you are working. Professor Suman, our this interaction is will largely be based upon these areas. Along with the project, one of your projects was recently displayed in first ever R&D fair which was conducted in IIT Delhi on 14th and 15th of October 2022. And the project was Covirap for rapid detection of COVID-1. So you are the person who has actually done marvelous work in COVID also in the form of Covirap. So I have made some kind of interaction points here for the discussion.
Sure.
But I will start with the project itself. So I request you to please tell all my viewers here what is Covirap and what is Covirap for rapid detection of COVID.
Yeah, I mean, so I will tell you a bit of a background behind this. That typically early in the year 2020, suddenly the entire nation was, I would say, that disrupted.
Yes.
That's when this so-called COVID pandemic, it impacted us all on a sudden. So I can remember that it was sometimes in March 2020, before the entire nation went to a lockdown. And in fact, the last working week that we had physically before it happened. So I was having a discussion with one of my young colleagues, Professor Arindam Mandal, who is in fact my co-worker in this particular project.
Okay.
He specialized in infectious disease biology, where I am basically from the engineering background.
Okay.
So we were discussing about this prior to that situation. By that time, we heard that it is something that could impact us very badly, but still it was not very well known. So what we realized is that at the end, this could impact the entire world very adversely. But I would say one of the important ways in which to combat that is the early detection that somebody has this infection.
Yes.
Now here we could identify the challenge. The challenge is at the time the rapid tests were not very common. So people were going, people were sort of getting a natural advisory of doing the RT-PCR test. And by now, of course, RT-PCR test is a household name. All of us know about this, and I do not see anybody, listening to this who may not have at least once gone through, that RT-PCR test, maybe over the last 3 years.
Right.
Now, we have also understood, that over the years, these last 3 years, typically the RT-PCR test has got extremely common, subsidized to an extent that now I hear that even in the GEM portal, the government portal, people are proposing RT-PCR kits at even as low as maybe in the tune of 10-20 rupees like that. Kits, not the test cost.
Right.
Now that is a very sort of welcome sight, but that is also something which is very elusive and misleading. See, it is not just the cost of the kit that decides whether the test is going to be available for everyone. It requires an infrastructure, and the infrastructure is that real-time PCR machine, which has a one-time cost, in the tune of the real-time PCR machine will be saying Indian rupees around 20 lakhs, and mostly these are imported. These machines, and but say that for some good wish or government's intervention, this machine is made available to some place, but you require a lab which will be sort of conducive to run this test with lot of quality control, environment control. You need to have trained technicians who can do this test, and all what it means is that this test, more than the cost of the kit, it has the challenge of the infrastructure hunger that the test has. So clearly, no matter whether the kit is of 10 rupee, 5 rupee, even 0 rupee, it is not possible to implement it everywhere. This is something for which the entire nation has to build up an awareness. Otherwise, there will always be media hype that now RT-PCR test is available at say 5 rupee kit, 10 rupee kit like that. So considering that, it is therefore ruled out that no matter how cheap is the kit, no matter how easy is the test nowadays to conduct, you will simply not have the infrastructure everywhere to do. So it means that we need an alternative to the RT-PCR. Now over the past 2-3 years, the alternative that has very rapidly emerged is the so-called rapid antigen test.
Okay.
So that is that the common kit which is available nowadays even in the pharmacy shops, and you get the kit and you get your swab tested, almost self-tested at home. If you are really good enough to collect your own swab and do it, you can do it at home. So, but the challenge is, there are two types of challenges associated with that. One is the RT-PCR test, which is the very I would say gold standard in this area. Everybody believes the accuracy of this test.
Yes.
It is a test which is done on the nucleic acid. Okay. So for this novel coronavirus, it is the RNA, the ribonucleic acid, over which we do the test. So it is the nucleic acid where the fundamental genetic signature of the virus is, and therefore it is one of the very fundamental ways of detecting it. But the rapid antigen, it is based on some antigens or proteins in the periphery of the virus, and therefore if you have a very low viral load or maybe early stage of the infection, many times you get a false negative. That means you get a result which is negative, but at the end you are positive, and it is a very dangerous situation because you think that you do not have the disease, you mix with people, and in the way you may spread the disease silently. Your immune system may be strong so that you may not have symptoms, but some elderly or immunocompromised people can get severely affected by this. So on a community level, we should have something which should have accuracy of, like the RT-PCR test, but simplicity and user friendliness of the rapid test. And that is how we try to design the Covirap, which is a nucleic acid test, but disseminated in the form of a what we say, a very small portable box. You may have seen that unit in the R&D fair, Pan IIT R&D fair. It's a very small box which anybody can carry, about 400, 500 grams. So inside that you have two things. One is you have, see, for all these nucleic acid tests, you require two types of things to do. One is you convert the RNA to the DNA, which is called as reverse transcription. And then the second step is that you actually amplify the DNA. It is just like a photocopy machine. So you start with one DNA, but you very quickly, multiply, say, 1 to 10 to 100 to 1000, like that. In that way, the number of copies of the DNA becomes so significant that even if there is a little bit of, viral load, then with a large number of DNA, at least you are able to detect it by a optical signal that comes out during the reaction. So that is the basic principle. So you have to multiply the DNA, and to multiply the DNA in the real-time PCR machine, you have to do something called as thermal cycling. That means you heat and cool, like that. Now that requires a very sophisticated, equipment. Now what we did is, we used some known technology, which is basically, replacing this thermal cycle with a constant temperature process. I mean, you maintain certain constant temperatures, but we realized, there are so many factors associated with this. Say your swab is collected. Before doing this RT-PCR test, there is something which is called as RNA extraction. That is the ribonucleic acid extraction. And it takes it is also a procedure which you have to do in a very controlled unit. And that will again require infrastructure. So not really the cost of the kit that is of concern here. It is the quality control, infrastructure, all these things are very important, which you cannot easily do in rural places, where you do not have such a control. So what we did is, we replaced that also by an isothermal process, and one or two more isothermal steps to make sure that the result is very accurate. And we built up a machine where in the machine we could pre-program these isothermal steps. And in that way, we could have the full integration from the swab collection to the final result. And there is another point here, that to get the result of such a test, typically what happens, basically reactions take place in a closed unit because of the heating. That is what it happens. Now, after the reactions, if you want to study the products, in some of these types of tests, you have to bring the product out of your container where the reaction is taking place. Now, then the challenge is that once it comes out of the container, it gets exposed to the atmosphere, and if it's an uncontrolled room, say our common household place anywhere, it can very rapidly catch contaminants, and it can spoil the reaction. So what we did is that we designed a complete closed unit. We had a micro chamber. Inside that the reactions were taking place, and we never opened it back again. So in a closed unit, the reaction was taking place, and at the end of the reaction, there was a change in color. So what we did is, we used a smartphone in the same portable unit, took the picture of the products after the result of the test, and then based on that, we had several, this is like sort of what we say as training to the machine unit. So this training is we have certain data for which we have the result of this test from this machine and the RT-PCR test. So by that we have a correlation developed. So that means that if we have a color, and we know that what is going to be the result, if it is positive, negative, or whatever. And also nowadays we have adapted it to an extent that you can also tell us something like a CT value, which is the viral load in a different. So that color analysis, we made a image analysis algorithm, all interfaced by the smartphone app, and this we were doing for every gene that was being tested. And you may have noticed that, starting from the early days of the COVID, till now, there has been so much of, I would say, evolution of new strains. Like, first those, Delta, variant, and now, Omicron, and, several other things are evolving. And it will keep on evolving. So all what it means is that one particular gene, it may undergo mutation, during this, for the virus changing its nature. So one gene is not good enough. So we made it a multi-gene test. And we put a sort of algorithm. So out of those multiple genes, if the majority is saying that it is positive, then by some algorithm we are declaring it as positive. So in that way, this entire thing, that for which a real-time PCR machine would require not just a capital cost, but also the operational hazards, I would say. We all simplified that in the form of this magic box, where you put the sample, start, switch on the machine, the test will run for about 40 minutes, including all the steps. And then the result, the color, either it changes or doesn't change, whatever. But you don't depend on human interpretation. Only you have to take a smartphone picture, and the smartphone also is placed appropriately on the machine, for which there are, guidelines, basically boundary lines on which you put it. So, nobody can make any mistake. And then the picture comes, the app automatically does the analysis. You really don't have to do anything, and you will get the result of your COVID test. So this is what is the Covirap. So what it did is, it did not just make it a low cost. Of course, it is a low cost test, because the cost reduction comes from various sources. Number one, instead of the RT-PCR machine, you now have this low cost machine. This is around 8,000 to at the most 10,000 Indian rupees, as opposed to that 20 lakh machine. But that is not all. You can put up this machine anywhere. It's you can power it from a normal electrical source. You can run it through normal battery. You can also, in rural places, run it by other chargeable batteries, and in fact also by solar, other forms of energy. The device is very portable. You can put it up on a table, reasonably clean, but it does not have to be super of lab quality environment. You can engage any frontline worker to do the test, like typically maybe ASHA workers, or even the medicine shop, the so-called assistants in the medicine shops who are there to sell medicines, and maybe sometimes to collect blood samples and do small tests, give injections. Those people can do it. And even if well trained, or I would say that if we're careful enough, people can also do this as a self-test. I will come to the challenge of self-test later on, because it applies to everybody. But all in all, what I want to emphasize upon, that it is not the reduction of the cost per test as per se, but disruptive simplification of how the test is being done, so that you can bring a high-end molecular diagnostic test to maybe a very underserved place, down to earth, or in the grassroots level. So in that way, I think this is the sort of revolution that I'm expecting. But what I did not tell you so far, the real unique selling point is, even not all this. So the unique selling point of this test is that, when we started working on this technology, COVID was there in our mind. But we realized, and I shared with all my team members, I am the most experienced out of them, and also you can see some gray hairs in my hairline. So you'll realize, I have gone through much more experience than maybe my young team members. So what I realized is that COVID is there today, and when we started working on this, but the impact of COVID is not going to be everlasting in the same way in which it was there in the early days of the COVID. And we all have seen this in the Omicron, and as it evolved, it never became that deadly as it was there in the second wave. In the second wave, it just snatched life from people. People suddenly had that breathing problem and they passed away. So that didn't happen, and it is a very common thing in viral theory. My colleague Arindam explained me this, that it starts with a pandemic, but it ends up with an endemic where maybe large number of people in the community get infected and possibly they develop herd immunity or whatever it is. So it doesn't become that deadly as it used to be in the early days. So COVID will, it will become like that. But challenges will remain because infectious diseases are not gone. See, we have, for example, TB. One of the major sources of concern in a country like India. We have vector-borne diseases, like mosquito-borne, malaria, dengue, Japanese encephalitis. So many of these. We have other viral infections. For example, nowadays, because COVID is not that impactful, if we have a cough and cold or say running nose, that type of thing, so it could be even a common flu, seasonal flu, or it could be COVID, it could be something else also similar to that. So how do we distinguish between say COVID versus flu? So all what it means is that we need a platform technology for all these diseases, not just I would say one-piece solution for COVID. So what we made is that we made this technology a platform technology, which we call as piecewise isothermal nucleic acid testing or PNAT. And in fact, we got US patent on this platform technology and not really on the COVID detection. Although Covirap was initially introduced for COVID detection, but very recently we have got this US patent on this as a very, very new global technology for any nucleic acid based testing. So all what it means is that if you have a method for testing a nucleic acid for some particular virus or bacteria or parasite, for which there is a protocol nowadays for all we have the protocol available. So we can really tune the machine, pre-program the machine so that that protocol can be run in that machine and the test can be done. No change in the machine is required and no change in the app is required. It is just different reagents that we have to use for different machines. So that means one machine for all tests. Such a low cost, one in all magic box. That can be implemented at resource limited settings. So that is how I would say, it has been the evolution of Covirap. The day in which we started working, and frankly speaking, I have never done any work on molecular diagnostics earlier. I did work on other disease diagnostics using this small body fluid samples by the microfluidics technology that at the very beginning you mentioned. But I never worked on this. So I learned, this was an opportunity of learning. So I learned about the virus and how to detect the genes, etc., from my young colleague Arindam, who is the virology expert. My another young colleague Aditya, who is my who has been my student earlier and now co-faculty. He helped me in building up the machine which I designed for this purpose. We had an exciting team of very young and enthusiastic people with a combination of people from biology and engineering. And in fact, the person who collects the sample is also a part of this. And that is how, with this wholehearted teamwork, with all support from the institute, our director and everybody who has been behind us in very difficult time when all labs were closed and only our lab was open to do this work. So from that to different ministries, typically the Ministry of Science and Technology, the Ministry of Education, and the flagship program CRTDH, Common Research and Technology Development Hub on Affordable Healthcare, run by DSIR, Government of India, and last but not the least ICMR, who helped us in validating the test at various stages, including the ICMR NICED at Kolkata and ICMR RMRC, the regional center at Bhubaneswar, with their directors and other experts. So it has been really a team effort. I do not want to claim any individual credit for this, but all what I want to say is that I am so happy to see whatever I as an individual envisioned at a time when perhaps even none of my team members believed that our technology could come to that stage. Now we are really in a position, not just a make in India, but I would say a lead technology from India, which could create a global impact. And that is why I'm so sort of very optimistic. I would not say that I'm satisfied, that we tried to do our little best whatever we could do in our own capacity in sort of realizing the dream of our honorable Prime Minister.
So, Professor Suman, it is wonderful the way you explained everything and very elaborate explanation of Covirap. And I'm delighted to know the evolution of this entire technology and how you converted the adversity into the opportunity.
Yes.
And I congratulate you and your entire team for this wonderful work, Professor Suman.
Thank you very much. And I would say that it's a teamwork, and we have a long way to go, because as I told, that our objective was initially, of course, COVID. But now it is, I would say COVID plus plus, COVID and beyond.
Yes.
See, I know we have started believing that COVID is gone, but I would say no. Why? Because, it will remain like something like a flu.
Okay.
Many of us do not know, I mean, we may be knowing, but we are not that aware that flu every year takes so many lives. I mean, if you see the, death related to, flu, because, with flu, people who are immunocompromised get secondary infection maybe in lung, and they may get pneumonia and other things, and elderly people or immunocompromised people, they may actually, face, very severe challenges. They may have to be shifted to ICU and all these things. So all what it means is that even if it is in an endemic stage, we have to be careful.
Yes.
Not that we have to, panic. We have to continue, and we have to smoothen our day-to-day, work, because, that is where actually COVID impacted, I would say, more indirectly rather than directly, in terms of, people, getting not well treated because of other diseases, which were, very, very impactful, but they could not afford to get treatment because of the COVID-related challenges. People lost jobs, entire, economy, education, everything got disrupted.
Yes.
So now what I am imagining is that we can put up this as a regular screening device in maybe schools, hospitals, maybe I would say railway stations, airports, other community centers, maybe our common shopping centers, which we call as bazaars, not really the shopping mall, common Indian bazaars. So we can keep such units just like a kiosk and train some of the frontline workers to do very common screening. And none of us really like to get our nose poked continuously for this. So we are working on an alternative technology where you are just given a saline solution, you gargle the saline, and you just spit that in a small container, and this Covirap test is done with that. So it is a completely non-invasive thing and ideal for children.
Okay. Yeah.
Because children get very disturbed if you poke their nose, and you may have seen at your home also.
Yes. Yes.
So we can do it in a different way, where the accuracy may be a little bit compromised, but it gives us a freedom of repeating the test. Somebody is having a sort of consistent symptom, so it can be repeated, and once the viral load is picking up, it will be captured. So in that way, for massive grassroots level, community level screening, it requires, of course, a government mandate to do such things. But I want to look into it in a futuristic way. Maybe currently there is no advisory of this kind, but I think this is the future of infectious disease screening, where you don't disrupt human lives. See, lockdown is a very serious measure. It affects everybody. It may save lives for some people, but it is actually snatching away livelihood from many others. Typically the daily wage earners and so on. People like us who are professors, and maybe other people who are salaried people, we enjoy the government jobs and all. We are much more secure, and many of us therefore do not understand this challenge. We must be passionate enough to understand this challenge. Therefore, I think the preparedness for, I would say, future epidemic or pandemic management on a community level is to have extensive grassroots level screening, where we can continuously do the screening without disrupting any normal one. And whenever we see somebody infected, just isolate, and then take care of that. That will actually arrest so many of the adversities that these kinds of infectious diseases can.
Okay, Professor Suman, after listening to your entire thing, and I understood the benefits of Covirap vis-a-vis RT-PCR test which we were doing and all. But one question is coming to my mind, that is related to the commercial and financial viability of this product, because
Yes.
this RT-PCR was more or less the forced kind of thing on the citizen or people when their travel restrictions were there and all. So everybody was forced to do those tests. Given the
Yes.
choice, people may not go for those kind of things.
Yes. Yes.
So how do you find during no COVID situations or during normal situations, the Covirap which you have designed and which you have made, that will be sold, and commercial viability will be retained in these kind of products?
Yes, yes. So, first of all, this technology has actually been transferred to companies, both the Indian, company and foreign companies. And IIT Kharagpur has transferred that technology through our technology transfer license agreement. What it means is that these companies, of course, they are entitled to sell this technology, and in a format which we of course initially befitting for COVID, and so they have proceeded advanced to a great extent in a way that they have got test license, and all the regulatory processes are now almost towards completion before it is actually put up in the market. The commercial version of the machine is there. It was displayed in the Pan IIT R&D fair. So it is there in place, and few other regulatory final checklists are being cleared. Now the question is, it's a more important question. Even if it is there as a sort of a licensed technology, what will be the viability of a company who is going to run the test? In terms of their commercial benefits, because this is also very important. I mean, all of us want to do good social service, but not at the expense of maybe our own sort of say company interest. So in that way, what we are trying to do is trying to put it up as a kind of platform technology. First, because the device has been extensively tested for both COVID and flu. So we are trying to put up a value proposition through these commercial partners, where the doctor, say, within 30 minutes will get a recommendation whether it is COVID or maybe common flu. Okay. So in that way, see, at this stage it is very critical, as I told you, because now COVID is almost like common flu in terms of symptoms and several other things. So in that way, I would say that the future commercial use of this Covirap is possibly a differential diagnostics for patients for whom maybe there are certain very, very generic symptoms which could be for different types of maybe viral or other types of infections. So I would say that more on extensive infectious disease management for different diseases rather than COVID as a standalone solution.
Okay. So, Professor, this do you think that COVID is going to stay for long in one form or the other of its strain?
Yeah, it will stay, but the question is that there are so many other diseases also which are staying.
Okay.
So in that way, it is perhaps the right time where we be aware of COVID. We do a lot of screening, but we do not over panic on COVID as we have done over the past 2 years. So let it be a part and parcel of our life as several other infectious diseases. They have not gone. Right? So in that way, let us accept this as a part of our life and try to see two things to happen. Number one, that people are screened early, and number two, a large number of people are under the vaccination program. So that if you have a combination of these, because why the combination is required, we have learned a lesson that even with double dose vaccination, people are getting infected by COVID. And it has happened very much. But what we have also seen is that possibly the good positive thing about vaccination is that at least from I cannot say it on a complete statistical basis, but from my personal experience, people who have got double dose vaccine and still infected by COVID possibly had less chance of getting life-threatening symptoms.
That's true.
Somehow they could manage it in some way or the other. Whereas those who were not vaccinated, particularly the early days, many of them could not survive. So I would say that vaccination and then possibly booster dose at a recommended interval, and then getting community level screen quite regularly. If somebody has a combination of these, then on a say overall societal perspective, we will resume our daily work. If somebody is affected by COVID, just like normal, we should have a isolation protocol, whatever is ICMR telling us, maybe 3 days, 7 days, whatever, and then the person may come back to office. Very similar our work, very similar like our childhood we had pox. So we remained isolated for some time, and then we came back to our school or college, whatever. Same thing can be there. We should not be, I would say, very, very panicked about it.
Professor Suman, before I go forward and discuss more about your other areas of research, I was getting interested to know about your academic journey, which was extraordinarily, this is good. And you are a researcher par excellence, and not only that, you are also serial entrepreneur. That is what I will discuss a little later. I could not help myself observing like you are gate rank 1 in 1997. After that, you did your PhD from IIT Bangalore in a solid liquid phase transition during thermal processing of material, and it was adjudged as one of the best PhD thesis. And you joined IIT Kharagpur in 2002, and within 6 years you became professor. So that is extraordinarily good academic journey. I want you to share your academic journey with all those who look forward to pursue such kind of really good journey in the academics.
I mean, of course, it is extremely satisfying, to do well in terms of these pointers. I would say that, say for example, All India rank 1 in a national competitive exam like GATE, and then sort of being recognized for your PhD work and getting quickly promoted to full professor position, perhaps quicker than many others. First of all, I would like to mention two things. First of all, it is not just my credit. It is again just like as I said that Covirap is a teamwork. So to say, the entire academic journey has been a teamwork because of very silent contributions of many people. At an early age, of course, my parents, who sacrificed extremely, for bringing me up. To now where I have the sacrifice of my wife and maybe a patient understanding of my son, for everything that I am doing, even at a senior age, with no less enthusiasm than what he used to do maybe 20 years back. So a lot of family support, a lot of support from I would imagine my teachers, and starting from the school teachers, high school teachers, my college teachers, and in particular my mentor and thesis advisor, Professor Pradeep Datta from IIT Bangalore, who mentored me exceptionally and still mentors in very difficult situations. I'm also now in administration, so sometimes I face really kind of challenging situations, and I still look up to him to get some advice. And my mentors from other from other settings, all professors like the late Professor S.K. Shom, who has been a mentor at IIT Kharagpur. Several others. I would not please they should pardon me because I cannot name everybody in this limited time. From outside India, my research mentor in two very key areas in which I have researched. One in fluid dynamics, Professor Franz Durst from Germany, and Professor Mark Madu from University of California at Irvine, who has been my mentor in microfluidics. So all in all, we have I have been mentored by exceptional people. I have been sort of I would say blessed because of an outstanding family support, starting from parents to my spouse and child, and over and above outstanding, I would say, set of students from my early career as a faculty member. And almost so I have till now more than 45 PhD students have passed. I mean, they have got PhD degree with my supervision. And a large number of them are extremely well established in as academicians both in India and abroad, and as industry experts in both India and abroad. And all what it means is that it cannot be my individual credit. Whatever I could acquire is because of, I would say, silent support work from many others whom I cannot name individually.
Yes.
But I would say that collectively they could make a difference. And regarding all these pointers, I'm so happy that I could, of course, get these good pointers which I can still mention in my CV. Even years have passed by, so my grades in maybe IIT Bangalore, that Senate commendation, or GATE rank number 1. All these things are so nice. But and PhD thesis being awarded internationally and nationally. But I would say that I never actually planned to do all this. These things came out of I would say more of a coincidence. Like I gave my efforts, my associates gave their efforts, and then good fortune. In everything what you try in life, grace of Almighty, I would say, to generalize. All these things are very important. Even if you keep on trying, you may not succeed.
Yes.
Sometimes it happens, and I had gone through extreme tough patches. People know only success stories. But all these things I have gone through. Life is like this kind of sine curve. It goes up and down. And I have realized, and these things come and go. But only you can, if you are patient and you stick to things, and if you are working hard and you have blessings and support of everybody, possibly good things may follow. And that is what has happened. So I would say that while I'm very happy with all these things, I would not like to credit myself too much for all these. It happened, and I accepted it.
Professor Suman, since beginning of our interaction, you are mentioning about your co-collaborators or colleagues like Arindam, Aditya. I believe they are youngsters, and they are mentorship also. They are your mentorship also. So any good invention or research requires interdisciplinary approach, as you mentioned, biology, mechanical engineering, and all. So my question is related to that only, Professor Suman, that how important is collaboration with academia or with industries for such kind of translational research which you have done, and how difficult it is to collaborate? Because if our researchers start understanding the meaning of that, certainly good things will pop up. So how important is such kind of collaboration, and how difficult it is to do that?
It is an excellent question, I would say. And in fact, this is something which I always like to answer, even if I am not asked. I would imagine. Because I would say this is the toughest hurdle in all the research that I do. That is why I want to emphasize, not nothing more than that. So if you see that, if you look at our upbringing, see, in schools, we thought everything as compartmentalized. We ourselves, classified, say, subjects of science. In those days, we called arts. Nowadays, what we call as humanities, etc. So science, arts, maybe commerce, whatever. So these were very compartmentalized subjects. And in fact, within science, we had, subjects like physics and mathematics in some category which we thought more mathematical. Chemistry, maybe a bit of, bridge between, something which is mathematical of that type, and maybe life sciences, which in the school we thought more descriptive, rather than, having that element of, mathematical rigor in that. That is the school life impression. And I would say this is the, most wrong impression that all of us, carried at that point of time. Now, when I became a sort of student who could take independent decision, the first decision that I took is that I would never go for study of biology and medicine. At that time, I never knew that by circumstances or fate, whatever, at some point of time I would become the head of the School of Medical Science and Technology at IIT Kharagpur. I never realized that. So I learned through experience, because I have no hesitation to confess that at that time my idea of education was one-dimensional. I thought that I loved physics and maths, so I wanted to do something in my career where I could potentially use a lot of physics and maths. And also I wanted to have a secured career. Otherwise, maybe I would have taken physics and maths as my studies. And in those days, it was told that engineering is going to give you a more secured career in different directions. Need not necessarily be in engineering. It could be in IT or commerce, anywhere. So that prompted me to all of us want to have a secured career at the end. So it prompted me to take up that career, and mechanical engineering was one of my choices, although I could get into maybe computer science at that time. But I always wanted I loved machines in a way that in my young days when I used to have toys or even pens, my first job is to open them up and dismantle them, and in the process actually I destroyed many such things in my very young days. But I love to do all those things. So I realized that maybe a good compromise between what I love to do and maybe the maths and physics, what I enjoyed picking up in my senior days. But when I came to research, I figured out that the real life challenge, be it industry or human life, is not compartmentalized. It is neither physics nor chemistry nor maths. See, we have challenges. Like in the real world, we have challenges on, say, energy, for example. We want clean energy. We want good quality water. We want affordable healthcare. We want transportation system infrastructure. These are, and we want all of them sustainable, eco-friendly, and helping the society, helping the economy. So can any one of us tell that what is this subject? Is it mechanical engineering? Is it mathematics? It is actually I would say, a gel of everything. So that over the time I picked up. And in fact, humanities, social science, all those things become so important. Even language. We need to communicate. See, I may have done great things, but what I am doing here is that I am trying to simplify these to people who are not very well familiar with this thing. They may be great experts in their own field, but they may not be familiar with this. So it is also like communication and language. So all what it means is that whatever we have studied in all from school to college, university, and whatever others are studying, the first thing is that we have to be respectful in the need of that. And that is, I think, the first sort of prerequisite for collaboration. You have to respect.
Yes.
So once you respect others, maybe say say let me give that Arindam. Arindam is a biologist. I mean, he's a chemist and sort of evolved in the form of a biologist, and his expertise is virology. That is viral disease detection, management, etc. So now when I collaborated with him, and I have collaborated with many doctors are my collaborators. I think the greatest barrier is, number one, whatever ego we have among us, about our own knowledge, and our sort of inappropriate communication or exchange of ideas. So for example, if Arindam is speaking with me and telling about, say, 10 biology jargons which I have never studied, I will develop an apathy. I mean, I will develop a fear, and I will say that no, this is not my cup of tea. Similarly, if I talk about some 10 big equations and mathematical equations to a virology expert like Arindam, he will think no, this is this is mathematical fluid mechanics. It is not my cup of tea. So the art of, or the act of doing such interdisciplinary work is to have a team of like-minded people who are very eager to exchange ideas, learn from each other, irrespective of the age. See, it doesn't matter what is my age. Whatever is my age, say X, maybe Arindam's age is Y. Y is less than X. Now, that doesn't mean that I am superior to Arindam. See, all the things that he has acquired by virtue of his training, he knows better than me. And I have never been trained in those subjects.
Yes,
and whatever I know, also, I have been trained, and he has not learned that. And so, if we have mutual respect, we can debate. There have been times when, Arindam said, no, sir, it will not work. This is something which will, such a device will never work in practice. Now I had to be patient. I had to realize that Arindam is not really insulting me, as a senior academician. It is just a healthy, scientific or technical debate going on. And that is how, we gelled as a team. And sort of we created certain black box items where my input, his output, and maybe my output is his input. And in my domain, he is not encroaching. In his domain, I am not encroaching. But we are putting our bits and pieces into that broad framework where doctors come in, technicians come in, people from other branches of engineering. For example, we have a couple of extremely bright computer science undergraduate students who are there in my team and working on the mobile app, with different codes, starting with their expertise in Python coding and all these things. And but the thing is that where I come in is that I have to explain to them what they have to do, and then they can code it. Because it is not just like coding a finance problem and coding such a technical problem is not the same. You understand what is the technical thing and scientific thing going on. So that is where I have to sit with them. But in that way we have people from electronics, people from manufacturing, people from mechanical engineering, people from biology and chemistry, and healthcare workers and medical doctors who are validating our things. And last but not the least, the frontline health workers, the rural women who are actually making our test disseminated for common people. So everybody is a very important stakeholder. In fact, when they make use of the machine, they tell us that this is where it could have been better. It could have been more user friendly. And we like to take that as a sort of input and make our design better.
Very good.
So that communication, this is something which can make, I would say, an interdisciplinary project successful. But there is another point which is very much related to the industrial connect that you talked about in one of the points. See, even with this interdisciplinary viewpoint, as academicians, we can only come to a stage where we have a prototype which we can demonstrate that it works, but we do not have really that training to really make it commercially viable. Until and unless say I am a management expert or commercialization expert. There are such academicians also, but normally like people who are engineering professors like me, or maybe a science professor like Arindam, it is not possible for us to really get into that. So what we say is that last mile, and that is the decisive one, the lab to market, from lab to the finished product. And this is where I would say most of the academicians falter. So we publish papers, we have patents, so we have all the checklists which are needed for any academician to have a very successful career, be a student, be a teacher. We can make our careers out of publishing good papers, maybe getting patents, supervising theses, doing projects. All those things are there in our career sort of checklists, which get us promoted, which get students jobs after they do their research degrees. But these are not sufficient to bring a product for use. So for that, you require that bit of an entrepreneurial flavor. But you either champion an entrepreneurship, or you do it in a sort of a hybrid mode where you use your scientific and entrepreneurial mind to get it translated with the help of other people who are by profession entrepreneurs, full-time entrepreneurs. And that is what I think is the need of the, I would say, era. If the Indian research has to really come up with innovations which will compete in the market, not such make in India where we blindly copy others, but innovate in India and make that into products. That will actually take us to the self-reliant India or Atmanirbhar Bharat.
So very wonderfully said. Couple of last lines, Professor Suman. Like, we should not run after make in India and copy paste. We should innovate in India. That will make us self-reliant. These are the beautiful lines I've ever heard, Professor Suman. And also this question which you have answered, I would like to summarize what I understood related to collaboration. You said for collaboration, you need to follow certain things. Number one, you should have respect for individual differences. You need to respect the team members you have. You need to basically have this particular fear and apathy you are to avoid. You need to be good in communication. You are to avoid your egos, and you need to come out of that pigeonhole mentality and compartmentalization that should not be there. So these are the couple of things which you have mentioned for better
exactly. I mean,
and
well summarized. I mean, these are the main points.
Yes, and I'm very sure the new researchers which must be listening to us, they will get tremendously benefited by your ideas, Professor, and that is the need of the hour. Very wonderfully said. Now, next related question I would like to ask you, since you mentioned about the entrepreneurial thing, Professor, I had this question in my mind to ask you. When we see if we want to create Make in India or become self-reliant, we need thousands and lakhs of entrepreneurs. And what can be the better breeding grounds than premium institutes like IITs? Now, Professor, you are sitting at a position where you can become, the engine for such kind of growth, where entrepreneurial culture is created from the institutes like yours. So I want to ask you, like, can a professor in IIT also become entrepreneur? And I know you are. I know you have some startup companies also. So what is your opinion about this, and how to make a balance? Because it is going to be challenging. That balance between the teaching, the research, the venture, the family. So how difficult it is?
Yeah, absolutely. I mean, this act of balance is very important. So overall, there are, say two, broad acts of balance. That is balance between professional and personal.
Yes.
So, where you have your family, your, near and dear ones, and that is where, it is always challenging. But where there is a will, there is a way.
Yes.
I mean, sometimes many of my professional works, I have my family, accompanying, and sometimes they are there with me in all toughness or good times, whatever. And we also have sightseeing and other things, and you have to also have a very understanding family. I'm so lucky that they understand so much. My wife knows my challenge, even my son knows my challenge, and they all I would say more than happily cooperate. And sometimes they become parts and parcels of it. Like I can give one example. In the last Pan IIT R&D fair, I mean, where you have visited our stall, we were having a video shooting in one of these things, and there we were demonstrating the point of care test. And my wife actually volunteered to have her finger pricked for demonstrating the test, more than anything else. So you can realize, how much it is, so strongly connected with our family emotions.
Yes.
Otherwise, people will, see it from the side, but they will not actually come in the forefront and, take part like that. She knows all my team members, and almost like in a sort of in a motherly way, she tries to interface with them, and both motherly and friendly. You can understand that we are old, but not that old. So we are sort of not like really mothers of us, or fathers of us, students in that age way. But that like guardian like, or it's a friendly way. So that thing is there. So I would say that our campus life also helps. So it's sort of I would say mix, I would say intermingling of professional and personal, but it's very different to distinguish what is that. And what I have made see, I have lots of other hobbies which are different from maybe academics. Like I like to play cricket, for example.
Okay.
So whenever I have time, I go out with my son, and I am never I am no more that energetic which I used to be at that young days. So I always struggle fielding those balls when he is hitting with all his full force. But I enjoy really spending that time. And in a different way also, I used to follow Sachin Tendulkar very, very closely in terms of his philosophy of success. We are of the same age group actually.
Okay.
So when I was in class 10 and struggling for my board exam, I saw him fighting against Pakistan in the deadly pitches of Pakistan with Waqar Yunus, Wasim Akram, and those deadly bowlers. So that element of respect came, and then somebody of my age is doing that, and I'm only struggling for preparing for my board exam. So what I realized, I got one lesson from one thing, from him. Maybe he had never explicitly told that if you want to do well in something, perhaps you make your profession a hobby and your hobby a profession, right? Cricket has been his passion and cricket has been his profession.
Yes.
He never actually perhaps tried to very consciously differentiate between these two. And I think that is one of the greatest recipes of his success.
Yes.
So what I would say is that whatever we like to do, see, I like to work on new technologies or new innovations, very exciting publications where there is some innovation. And these I want to do like a hobby. I'm like people who like to write stories and all. Writing a paper is like writing a story for me. I enjoy that. So all in all, what I want to say is that sort of very little differentiation between your hobby, personal and professional thing, and gelling them all together in a, I would say, wholesome aspect of your viewpoint of life is something which will make you move along. Whether you are successful or not, that many other factors are there, but you simply move along. That much you can say. And regarding that the next final distinction, that is, if you are an entrepreneur, you are also a teacher, you are also a sort of research advisor, and I am also an administrator, like I am the Dean R&D of IIT. So you can understand these are all very different challenging jobs. These jobs have their individual challenges, and no matter whether you like or not, you have to deliver because you are accountable for what you are doing. And my philosophy is that even if I do a little bit of thing, and if I take the responsibility, I will do seriously, no matter whether I like it or not. So all in all, what you have to have, again, a good partitioning of your time for whatever you want to do, and not getting over carried with something, and then have an excellent team to work on. And most importantly, what I say is have trust on your colleagues. See, I mean, entrepreneurship. See, I have my startup, you know very well. And who are the members of the startup? The members of the startup are again either my students, maybe former students, or other colleagues with whom I have worked, who have not been my students, but maybe technical staff in some of my projects, and later on, they have become part of my startup. So what I do in the startup, if you say, what is my work? So my work is more like a scientific mentorship and advisory level, because where I have to see, where is my importance? My importance is not going to a bank and say waiting in a queue for 2 hours to complete a bank account, account opening. That is where is not my uniqueness. But if I do not have a trust on my team members, I will at least sit with them and try to do the job. And that is, I think, I would say the poorest of leadership and teamwork. That means you do not actually have trust on people. So what how I want to and how I actually plan to manage my time is to actually devote on something in which I am apparently indispensable. That means my experience, my expertise is absolutely necessary, and without that things cannot move. And that is how I balance all these works, and rest I would depend on my extremely capable and passionate team.
Truly, sir, Professor Suman. So it is all about time management, and it is challenging, but you need to have very good combination of people around you, family, and everything, and that is where the difference comes. So, Professor Suman, I have a couple of more things to ask you. One of the things came from your side only, that at one point of time you were heading the School of Medical Sciences, if I heard that properly.
Yes.
So I want to ask you, sir, how mechanical engineering background person can head a School of Medical Science?
Yeah, I will tell you, in a very simple way. See, all of us, go to doctors' chambers to get us treated. Have you ever looked into, nowadays what a doctor is doing? I have heard about the great Dr. B.C. Roy, Vidhan Chandra Roy. You may have heard about him, a very, very famous doctor, come, political lead in the, early, days of even IIT Kharagpur. Initially, also he was one of the masterminds, to build up, the first IIT at Kharagpur.
Yes.
So, he was, by training, a medical doctor, and there are, legendary sort of, anecdotes about him. That perhaps he used to stare at the patient, not even touch the patient, and get a feel of the disease.
Okay.
And these are certain legendary things I have heard. I have never had a chance of verifying that, because I have never heard of anybody who got treated by him. But these are certain legendary things which are carried over across generations in the medical colleges, at least in Calcutta, Kolkata. You will find if you talk with some of the present senior doctors who may have gone through their student life at that time. Now, but you look at a modern day doctor. If you go to a doctor, you will see that doctor will hardly touch you. And that you will, the doctor will listen to your thing, possibly, depending on the time that the doctor has. The doctor will touch you very, minimally, and then also talk with you minimally, and because he or she has to manage their patients, and will give us a list of diagnostic tests. Maybe starting from the low cost one to bit high end ones, depending on what he or she suspects. So what I have observed over the years, that it is a collection of medical devices and a very intelligent decision making, which we call as doctor's wisdom. See, I mean, I'll tell you an example. Say you have a headache. You go to a doctor. Now you tell the doctor, I have a headache. Now, as common people, we want a solution. I want my headache to be gone. I do not know whether, and I do not, in fact, want to know whether it is for some very, big technical termed disease or whatever. So then, what is his or her job is to sort of reduce that, or bring that down to maybe, say 1,000 possible options for which, if there could be a headache, to the final reason for which you have the headache. So what he or she will do, will actually ask you a few probing questions, maybe examine you physically for a few things, and use some very basic screening things like maybe temperature, pressure, etc., or nowadays oxygen saturation, whatever, and then ask you for some screening test, diagnostic test. So in that way, that 1,000 will come down to 100, 100 will come down to 10, and maybe then he will use some human intelligence and experience-based algorithm to put it down to 1. So my vision is that why can't we as technical people can convert or try to convert a doctor's mind to a sort of a cyber physical interface. That's why we have physical devices, which are medical devices, very much engineered devices, and with modern advent of data sciences like AI, ML, smartphone technology. Smartphone can do now almost everything, other than phoning. Phoning, sometimes we don't get network, but it can do all other things nowadays. Like watch can do everything, except for maybe, giving us the right time. So that is how, we have the gadgets, smart gadgets right now. So what I want to impress upon is that, nowadays medical world is more of, technology driven, rather than actually, experience driven. So in that way, I would, I had a realization, and this is again a continuous evolution of me as a researcher. Initially I actually never thought that maybe 50% of my research will be, working with human body fluid samples. I was greatly afraid of blood, and it was one of the additional reasons for which I never wanted to study medicine. So but what I realized is that major, again, this is a deterrent, just like interdisciplinary studies, that a lack of, say, synergy between doctors and scientists and engineers. We all live in a different world.
Yes.
So we need to have medical technology Whereas engineers, we should not develop technology as we feel as engineers should do. It should be something which should be relevant to a final clinical purpose for which the doctor is going to use.
Yes.
Number one. And number two, it has to be validated by them that, yes, it serves their purpose. Not something which is fancy, has nice electronics. There are many such gadgets now available in the market. Fancy electronic things, people love to use that as consumer items, but doctor have no faith on such things. So we should have a, back and forth synergy. That means engineers should innovate technologies. That technology should be as per the input of the doctor, and it should be again tested by a doctor, so that we converge on something which is a technological innovation and usable by a doctor for clinical reference. And that brings the perspective of the School of Medical Science and Technology.
Okay.
Our former director, again a legendary visionary, Professor Amitabh Ghosh, in the year 2001, he established this school, which was at that time the first school, and I would say department, so to say, in the institute, where a MTech type of degree was given to MBBS doctors. At that point of time, it was an unheard type of program in India. So this degree was known as MMST, Masters of Medical Science and Technology.
Okay.
So this prompted a lot of very talented MBBS doctors to come into the field of the medical technology, where they were going through this MTech type of program, which is something like you can say biomedical engineering for doctor students. If I simplify what it is. In that way, it developed a good generation of, I would say, a mix of research teams where you had doctors. In fact, I have one such doctor as a PhD student, who is an MBBS doctor, but my PhD student in technology.
Okay.
So in that way, we could have students, again, all good academic work is championed by students. And it evolved into a school which actually, when I was the head of the school, initially hesitated to take up that challenge, because previously I was confined in mechanical engineering as a researcher who worked in medical technology, but I never interfaced so much with these medical people. So the then director, Professor P.P. Chakraborty, he sort of kept his belief and faith on me, and he entrusted on me to build up that unit to an extent, that we set up a lot of collaborative program with leading medical institutes like the Tata Medical Center at Kolkata, which is the leading cancer research institute, AIMS New Delhi, and several other places, medical, big hospitals and medical units, different ICMR units, and it has, over the period of time, it has evolved in a way that we are going to be the first IIT to start our medical education program in the ambit of an IIT system. By looking into our initial footsteps, other IITs are also doing it. IISc Bangalore is doing it, but I would say that IIT Kharagpur has been the leader in it, and all that has been possible is because of, again, this intermingling of doctors, engineers, and other scientists and other expert scientists, and there the platform is the School of Medical Science and Technology. So it's not really a medical school, so to say, but it is a school where all the activities of medical science, engineering, technology are being worked out together with a team effort to bring, you can say, technologies from bench to bedside. That has been the vision of this, and I have been extremely honored to head this unit for 4 years before I became the Dean of the Research and Development at IIT.
Okay, so Professor Suman, I have already taken a lot of your time, but still there are a couple of very, very important inputs which I need from your side, sir. And one such is related to Common Research and Technology Development Hub, which we call CRTDH. Please tell us something about this, sir.
Yes, CRTDH is a flagship program from DSIR, the division of the Ministry of Science and Technology, Government of India, where the focus is scientific and industrial research. That's the Department of Scientific and Industrial Research. That is the DSIR. So DSIR has many such translational research schemes. Out of that, they have this CITDH and as one of their flagship schemes, Common Research and Technology Development Hub. There are certain verticals in which this hub is there. I think close to 20 such national hubs are currently existing. I mean, exact number I cannot remember, but it should be close to 20. Out of that, the flagship hub on affordable healthcare is being run by IIT Kharagpur.
Okay.
I will tell you a bit of background of what this hub is about and what it is doing. See, this is again, as a individual, I have advanced in my life, both personal and professional, by trying to always criticize myself. And we are all great admirers of the IIT system, but we also have to criticize ourselves to be even better. IIT system has done wonderfully well. Sometimes we have wrong comparison with maybe universities which have been as old as 300, 400, 500 years. Maybe the Oxfords and Cambridges or MITs, etc. Stanford and whatever. But we have to realize that we are only as old as our independence.
Yes.
Younger than that. So we have come up with leaps and bounds. But I think that there is a tremendous gap between what is expected out of us and what is being delivered. If you come to IIT Kharagpur, you will see that we have a flagship banner in front of the main building dedicated to the service of the nation. So this is very, very important. But if I ask to my conscience, the past 10 years, 10 years back, I started asking this question to me: what is that I have done to dedicate me to the service of the nation? I have enjoyed very good prestige all around the world. I have been there to several foreign organizations in the form of visiting professors, scientists, researchers, earned great prestige by being an IITian. We are all very much sort of in that way. IIT has given us a brand, but what we have returned against that. If you go say away from IIT Kharagpur to 500 meters, you will see entirely different scenario of extreme darkness. Darkness not in a literal sense that electricity is not there. I'm not talking about that. But in terms of, I would say, the privilege that the people are enjoying in terms of their livelihood. They are underserved. They have their own challenges. There is not much economic sustainability and self-reliance in terms of what they are doing. And this has been paining me a lot. That charity begins at home. We are doing great things by producing leaders as much as that the chief of Google, IIT Kharagpur is extremely proud to have, Mr. Pichai as, the chief of, one of the most respected organizations globally. And we have several such outstanding alumni. So we have done, great contributions in whatever way. But charity begins at home. If I cannot do it within 500 meters of where I am standing, it is my fault. We always as Indians, we always we are very argumentative. What Professor Amartya Sen, in fact, in one of his books he has written, and we always try to blame people. If I have not done well in my studies, I will always blame my father that he did not put me up in the right coaching center at my young age, instead of blaming myself that I have not studied. So we all blame government and so many things. But what we have IIT is what we have done. Now right at this juncture where my thought process was changing, I know one of the flagship programs of the Ministry of Science and Technology, Imprint. You may have heard of the Imprint program. It is like say a transforming research project program, a flagship program by the Ministry of Education, Government of India. It was launched by our Honorable Prime Minister about, I think, 6-7 years back in the Rashtrapati Bhavan. And where, I was, one of the coordinators in the healthcare sector of that. And there was something, where, our Prime Minister told, which actually impacted me very typically. What he said is that science is universal, but technology must be local. For a long period of time, IITs have been, why IITs? All great institutes in India have been, blindly following the footsteps of maybe what some, great professor is doing in the United States or, any other place. But their need and our national need is very much different. So while the underlying scientific theory may be, related, but we should disrupt, this, overall social and economic scenario by technology development, which impacts common people. And that is why we got the opportunity of CRTDH thanks to DSIR. So round about that time, we competed for this CRTDH sort of, project, and IIT Kharagpur, after going through that competitive grant, competition, we were awarded with the CRTDH. We developed that center where I was the PI, and still is now running in the second phase. And the whole mandate was to bring all these people in the, all these stakeholders in the ecosystem. So not just engineers, community people, like the common people who are suffering. So whatever healthcare technology we develop, we make them disseminated for these people. So at the end, the beneficiaries are common people. We are trying to reduce the community disease burdens, and who are actually, championing this? Frontline health workers, minimally trained rural guards, who, I would say that, we talk about women empowerment. There cannot be such a greater, scope of women empowerment. See, these girls, wonderful they are. With the training that we have given to them, they are now really disseminating the technology in the grassroots level, doing the diagnostic tests by themselves, which normally lab technicians will do. In that way, they are earning their livelihood. And we are also training the MSMEs, the micro, small, and medium scale enterprises, to be a part in this supply chain of these new technologies, to manufacture these devices and to understand the regulatory processes, so that they can also form, starting from their small nucleus to micro enterprises, and then form the regular enterprise, which we call as startup. So that thing for underprivileged people who never thought of using technology for that, for a long period of time, they were doing what we say in the Indian language, either jugaad technology or idhar ka maal udhar type of business. So we wanted to convert them to real cutting edge, deep science being used for the technology development, cutting edge technology development. And this CRTDH, again thanks to DSIR, Government of India, they have given us a platform to build up this center. So at IIT Kharagpur, we have this center on affordable healthcare, where we have training, device technology development, and the human resource management for dissemination to the grassroots level community. And that is how I think we are slowly progressing towards this, I would say, a sustainable community and livelihood, so that, at least that dedicated to the service of the nation, we can make a little bit of justice to what IIT professors we are all doing.
Professor Suman, you are also authority on one of the very, very important research area, which is called microfluidic technological research. So next, my two interaction points are related to that only, Professor Suman. First, I want you to please tell us, you are the inventor of paper and pencil microfluidic technology. So we would like you to tell us about that. And second, in line of that, you please also tell us something about the research inspired teaching lab which you have established for microfluidics, first of its kind, where innovated frugal open source benchtop experimental rigs have subsequently been advanced to develop the industrial products. So these two things, sir.
Yeah. So paper and pencil microfluidics is again something which is very close to my heart.
Okay.
Because again what I emphasize upon is that as engineers, even in the greatest of the Indian minds, you will see that we are very good followers, but not that great leaders. So in the microfluidics domain, I found is that there are great visionary leaders all around the world. In India, I was the first academic person to introduce microfluidics in academic research. But it has been there globally prior to that. So what I realized is that again, this difference remains, that there are extremely resourced labs, microfluidics labs. I have been, for example, as a visiting professor in the Stanford Microfluidics Research Lab, one of the best microfluidics labs in the world, run by Professor Juan Santiago, again, one of the leading professors in the field. So what I have seen in his lab, and I have tried to learn also a lot from that, is that, well, there are, extremely resource things these labs have. But in India, with the kind of resource that we have, how can we have such similar things? See, as IITs or ISC, we develop ivory towers, which are not accessible to others, then we cannot scale this up. So when I, in my early days, when I used to work on microfluidics technology, where most of these were advanced technology based, and I used to visit various, colleges and even schools. I am a lot of, I have a lot of interest in disseminating knowledge to school children. So I took part in various government programs for the school level dissemination of science. So what I realized is that the many people, many participants, they try to ask this very naive question, apparently naive question, that, sir, you have this in IIT, maybe you have developed this lab, but we at our place, we do not have this lab. So what you are telling is great things, but how can we make use of this? We can only listen to your talk and we feel that it is great, but we do not have that, resource to work on this. So this actually, sort of, triggered, my sort of imagination. And when I used to visit school, and those were my, early growing days of my son also. He was very young at that time. So I realized that, why can't we develop something where microfluidics can be practiced at junior school? And then I realized that in school, what we commonly use, paper, pencil, and eraser. Right? These are the three things that we commonly use, for our, whatever you do. Nowadays we have smart boards and all those things. But I do not think that these three things have become obsolete, and they will remain. So I thought that, can we make a diagnostic device technology with the use of these? So, the journey was not simple, because I will tell you the science is actually much more complicated than what I am now simplifying. So if you are testing with a finger prick blood, I talked about finger prick blood, that is why I am telling you. So instead of doing a elaborate lab test where somebody comes and put up a rubber tube and takes your blood from the vein, that normal blood test that you do, we know this acute check or that kind of thing, where you prick your finger, take one drop of blood, and in principle, in the microfluidics technology, because it takes only a small volume of the fluid, it can actually in principle do large number of tests using that drop of blood. But how do you do the test? You take the blood, maybe put it on a strip, be it paper or wherever, and you may have certain reagents which you use in the lab, and the blood will react with the reagent, and in some cases, in the common frugal technologies, it will change the color, which we capture by a smartphone and do machine learning based analytics. That is what nowadays we do. It's like you have a strip which is like a credit card, and your small portable box where you this small optics and electronics is there is like the credit card reader, where you are inserting it to do the image analysis. It's very simple, anybody can use. But the blood, say you have the blood. Now the blood has the blood cells and it has the plasma, the watery component. So you have to separate the plasma from the blood, and therefore you have to pass it through something called as a micro channel. I am telling a bit technical. I don't want to. I do not intend to do that. But the whole idea is that you need to make some tiny channels in the paper to make the that watery component of the blood flow. It will go to a spot where the reaction will be done. But it moves by a capillary action. What is capillary action? The same action by which water is sucked from the ground to the tallest branches of a tree. So, but it is a slow process. So if you want to make the test really work fast, all of us wants a 30-second answer, 1 minute answer like that. Then you have to speed up the movement of this blood, maybe whatever fluid. So you can use electric field actually, drive the sample much faster. This technology is known as electrokinetics. Is one of the building blocks of microfluidics. Now the challenge is that how can you make that electrokinetics on a paper strip? Because the procedure of this this microfluidic technology is very advanced in fabrication. It is almost like the semiconductor chip manufacturing. Same quality control is used, but you cannot make use of such thing in a academic small unit. So what I thought is that, see, and then you have to make an electrode. So electrode will be a conductive material and a very simple physics. So and all of us know that nowadays graphene is a very important material. People got Nobel Prize in graphene technology as one of the important emerging materials. The pencil tip, the lead, has graphite. So if you make a sort of pencil sketch, actually you are sort of depositing that graphite. So I thought that if you make a pencil sketch on a design and then connect it with the simple copper wire, then we could actually build up an electrical potential around that if we have a small power source like a battery. So when I first told this to my students, that reaction was really not they thought that either I was joking or maybe with years of stress in research I have become completely mad, whatever it is. But and then Indian students are very obedient and diligent. So maybe with a sort of with a hope that I would be satisfied if they try it out, they tried it out. And then within a few days they reported to me that, sir, yes, it is working. So what we did is, it's a strip of paper on which we make a pencil sketch HB. HB can pencil sketch, a small wire that connects that, and put a small battery, dispense the blood sample and apply that electric field. Magically the blood moves. So all what you require is a paper strip, which you design in a, you may design even in a word processing software, get it printed in a piece of paper by your office computer. There is a small heating step there to make that printing very solid, so that the toner particles, it will block the, papers have tiny pores. So if those are blocked, then the blood will not be diffused. It will just move along a line, and then you make pencil sketched electrodes. So all what you require is a computer, a printer, a piece of paper, and a nice HB pencil to make a medical diagnostic device. This we invented in the year, if I remember correctly, possibly 2011, in one of the flagship journals in microfluidics, Lab on a Chip. It's a Royal Society of Chemistry journal. It got published, and then IIT Kharagpur was recognized, and in fact our research group was recognized as the first group to introduce paper and pencil microfluidics. This was termed by other leading researchers in the world as paper and pencil microfluidics. And this work is now being followed by several labs in the world, which are doing independent research. We are also doing, but I think others are doing more than what we are doing. And it gives us a satisfaction that at least for one instance, we showed that we can become a leader rather than a follower, even in a little thing that we could do.
Wonderful, wonderful. So, Professor, about this lab, why this research-inspired teaching lab? What is the why the name? Yeah.
So now it's a continuation of the same point. So now when I was talking about the microfluidics lab, so for example, if I compare the Stanford microfluidics lab with IIT Kharagpur microfluidics lab, there is no comparison of the budget of the two labs, but we expect the same scientific work to be done. So whatever through research, what we say as the simplified technologies or frugal technology, whatever you call, whatever I could develop in the form of high-end science, in the form of simple say work benches or test benches or laboratory setups, even which could be disseminated in the school. I tried to develop such setups in our lab, which is open to everybody, Even anybody outside can make use of it. And in the process, we try to combine various units and machines to form, say, product development thing, which is an open source. And through the CRTDH, for example, we have developed an open source machine which can convert, say, a raw paper into a finished paper strip for medical diagnostics. And this is available to anybody, maybe industrial person, maybe just a common inquisitive person, school student, college student, anybody. So that is where is my vision. I mean, research should not be compartmentalized to be, have a distinction between haves and have-nots. Any technology should not be having a distinction where people are, economically privileged will have the benefit. Everybody has intelligence, and everybody has the same human right to, have, say, good health, well-being. These are United Nations, sustainable development pointers. So there's, we should have certain labs, certain technologies, may not be everywhere, but at least as a leading IIT, where it should not have a distinction. It should be simple, usable by everybody, and openly workable as open source material. And that is how, from the first day of the microfluidics lab at IIT Kharagpur to today, whatever we are having now, this is what is my vision.
Wonderful. So, Professor Suman, as I addressed to you earlier also, you are a serial entrepreneur and innovator and inventor. So, one of your another innovation is related to biomimetic tumor on a chip technology, if I'm pronouncing it properly.
Yes.
For unleashing mechanism of cancer progression. So, we want to know about this innovation from you, sir.
Okay. So, this is also an invention which I took part in one of my early days, and in fact, again, repeatedly that interdisciplinary research came in, in the discussion here also. So when I was a sort of very young faculty member, I got a very enthusiastic, outstanding undergraduate student from our Department of Biotechnology, IIT Kharagpur. His name is Tamal. And he is currently a faculty member at TIFR Hyderabad. So he was a BTech student at that time, and one of his friends, Siddhartha, used to work with me in more mechanical engineering oriented microfluidics. But because they were close friends from the same hostel, and they used to enjoy possibly meals together and all those things. So one day Tamal, he came to me. And he was very fascinated with the microfluidics technology because nobody else talked about that at that point of time in India. He looked into the net and he said that, sir, I want to continue with this as my PhD after I do my BTech. So I said, fine, but I am not really an expert in all the biological things. So I started collaborating with another very senior professor from biotechnology, recently retired Professor T.K. Maith from our biotechnology department. So what happened is that this was my learning phase, and very interesting. I share it with Tamal. So I made a sort of a pact between him and me. So every day, once for 1 hour sitting in the night, he would answer all the questions that I had on cell biology because he was trained in that, and I would answer all the questions in fluid dynamics because I am trained in that. And at that time I was a very young faculty, so our age difference was not that much. So almost like friends, he was like a younger brother to me. And in that process we invented this. So the objective of this was, see, all of us know that cancer is very deadly. There is no discussion needed for this. But also we know that in early stage, if it is detected, it becomes quite curable now. If it is treated properly. The greatest challenge comes to cancer management when it comes to the end stages. When the cancer cell from its origin moves to a distant place, maybe it's a primary tumor at some place in the human body, but it has gone to some other location and created a new cancer there. So what we say as cancer has spread around the body. So in that process, the cancer cell migrates through very tiny capillary vessels in the human body, which is like microchannel human body, which we call as microcapillaries. Now, our greatest, I would say, one of the greatest questions which was at that time, that these cells are very small, right? These are about, say, 10 micron like this. The microchannels are also around, say, 10 microns. So when the cell is squeezing into that channel, the cell is extremely stressed. But how can the cancer cell survive and pass through that while a normal cell could not? Because if the cancer cell is not able to survive, it will not be able to go from, say a tumor in the brain, now it affects the lungs. Now how it will go like, it will sort of be destroyed before that, but it doesn't. That means there's a unique adaptation. But how? So we develop a engineered technology which we call as a tumor on a chip. So what is that technology? Is a micro channel based thing, which is a sort of human body on a micro channel mimicking environment. My later students actually made it more sophisticated to an extent that now we have made it almost like how the capillary network there is there in the human body. But at that time we had it much more simplified, but the physics still we studied very complex. That we put up a cell on the surface. So there are many adhering cells, like the HeLa cell, for example, which is the cervical cancer cell. So if we put up such a cell on a surface, then if you have a fluid flow, which in a human body is there, the cell will get stressed, and the cell will try to adjust itself by adjusting its shape, shape adaptation. So how does it do it? For that mechanism, we tried to develop a platform where the surface on which the cell was sitting is flexible, because human body vessels are flexible, and the cell was adapting to it and changing its shape, and we could develop a technology which is called as traction force microscopy on a chip, which by a very small microfluidic setup, we got a patent also out of that technology. So which will tell us that how the forces are distributed on a cell as it is there in a micropassage. And it gave us very, very significant learning of how the cancer cell adapts to a microenvironment during its end stage, which is called as metastasis. So a lot of further work actually triggered from that. And I think that now researchers are in a much better position to understand how such metastasis occurs, how the cancer cell invades. Even cancer is such a disease, even 1% we have not understood. But still, there has been some progress, and I am very optimistic that using this know-how, some solution for arresting the end stage, rapid progression of cancer will come in the next years. This is all what is my optimism.
Wonderful. So, Professor Suman, also portable spinning disc is another good initiative and a good technology which you are working. And this is used to perform a complete blood count test with virtually no resource. So, can you also tell us about this portable spinning disc? What is this all about?
Yes. So, this is something which is called as lab on a CD.
Okay.
And this is what I have learned from my mentor from University of California at Irvine, Professor Mark Madu.
Okay.
So it is a microfluidic technology that was globally existing. So all of many of us have heard of centrifuge. Centrifuge is a very big rotating thing.
Yes.
Which you use for some diagnostic laboratory, biology laboratory work. So what you do in centrifuge is you rotate a fluid. If it has materials of different density, the density will have different rotational force, the centrifugal force, and it will separate at different places. So you can, in principle, separate different components of the blood. Say red blood cell, white blood cell, platelet, and so on. And if you can separate, then you can do some kind of imaging and count them. And that is how you can do one of the ways in which you can do a full blood count. There are other possibilities also, like you can use a automated blood cell counter. Now nowadays you have this cytometer, flow counter, so many of these technologies are there. But these are all expensive technologies. So what we did is, by taking a lesson from that, we converted that to a frugal disc, which is like the now CDs are all outdated in computer. We have pen drive, but you imagine something of the size of a CD, but made of plastic. So you have a small motor by which you can rotate it. You drop one blood and you make this microfluidic channel designs and cut micro channels there, and you basically stack plastic layers to make this device. So it is just like how you make a burger. You have different layers you press together and make such a DC. You put a drop of maybe blood, urine, saliva, whatever. By rotation, it will move and it may separate its components. So you may separate the components and study them, or you may do medical diagnostics on that. The advantage is that by a single rotation, you can make for example, blood to move in different ways. So large number of tests you can parallelize and do together by just one drop. This is that spinning disk technique.
Wonderful. Professor Suman, I also want your insight on very puzzling antibiotic resistance in life-threatening infectious diseases.
Yeah, I mean, antibiotic resistance is a curse in the modern era.
Okay.
I mean, you may have heard that in many cases, the antibiotic resistance is something which makes our life very difficult, because when we are having bacterial infection and doctor gives antibiotic medicine, in many cases it is not working. So there are many reasons which are given to this. Typically in countries like us, there is overuse or abuse of antibiotics. That means, if you, for example, I have seen it very commonly. So you take a child to a pediatrician, and the child has a fever. So the pediatrician will almost like, as a Brahmastra, will give a antibiotic, a broad spectrum thing, so that, he understands what could be, the source of the disease. But in all probability, many of the things will become better if that medicine is given, although he specifically doesn't know what is the cause. Sometimes, there is lack of awareness, so we are taking antibiotic medicine, but we are not completing the course. Doctor is saying you take it for 5 days, twice a day or thrice a day. But after taking 2 days, our fever is gone. We are so happy, and we just forget. And even scientifically, the bacteria over a period of time, see, they also evolve naturally. So they evolve to an extent that they are now in a position to beat the medicine which are there to kill. So there are lots of this antibiotic resistant infections, and sometimes if the infection is hospital assisted, these become very acute and life threatening. For example, you can have hospital assisted urinary tract infection because of E. coli, and that can actually bring in life threat to a patient who was previously well and just caught this infection. Multiple drug resistant TB, tuberculosis.
Yes,
it's a great problem nationally. For many TBs, drug is not working. TB is detected, but drug is not working. So doctor has to have an understanding in a very personalized way that for this patient, will this drug work or not, given the patient is infected. So what we did is, we tried to find out a mechanism. Number one, of how, for example, this E. coli, they maybe move in a microchannel with a, say, chemical gradient, or basically a chemical given, say a drug or something given. But more importantly, to develop a detecting device where, for example, by cultured E. coli, which is coming out from the urine of the patient. So there are small spots in a paper, again a paper microfluidic device, but made in different folds. Like if you have heard of origami, the Japanese style of making things using a fold. So by a simple hand folding of these papers, and in there we are making small spots. You take that cultured sample, put one drop, and in different other layers, you put in each layer one drop of the medicine that you want to test. And then you bring this closer. You just sort of bring them in contact by simple folding. Within 3 to 4 hours, we have devised a colorimetric reaction that the original blue colored, say there is a chemical, if the antibiotic is killing the bacteria, that chemical will start converting, into pink color. So the fractional change in color will tell us how the bacteria is responding to the antibiotic. So if the doctor has an option of giving 4 possible medicines, the doctor can put up, 1 drop in each of these small circles, wait for 3-4 hours, which is not, that damaging. And because most of the diagnostic tests will require that minimal time in it. And then within those 4 hours, the doctor will, get a clear idea which medicine is likely to work for that patient or not, because that is being tested on that small volume of sample which is cultured by, taking the sample from that patient. So it's very personalized. And then the doctor can prescribe the medicine with a much greater chance that the medicine will work if the proper course of antibiotic is given. So, my former PhD student Shanti Moy, in collaboration with one ICMR researcher Asgir, they together developed this technology. So we have not just patented this in India, but ICMR has got greatly interested to file this patent in South Africa. And very recently, ICMR has decided to put up a South African patent for this technology, because perhaps again this is going to be one of the very important technologies developed in India which could impact underserved communities also.
Wonderful. So, Professor Suman, we have come to almost an end of this wonderful session, but I want your view on, in fact, you have done marvelous work in the field of rural healthcare. We want to know from you, sir, how your technology is helping the rural people in the field of rural healthcare.
Yeah, I mean, I think I gave the answer in part earlier through the that CRTDH, what we function.
Yes.
So first of all, see, if you are imagining yourself as a underserved rural person, see what is the challenge when you are ill. See, you cannot readily go to a high-end medical center. So you require a solution. So very recently we have developed a oral cancer screening technology. So oral cancer is a very dangerous, it's one of the top 5 killers in cancer in India.
Right.
So typically the oral cancer, although this is not the only source, but a common community level source is the chewing habit with tobacco and gutka and all these things. So over a period of time, if these people are not compensating that with good oral hygiene practice, then they may develop certain lesions inside the mouth, which develop into something which is called as pre-cancer. This is in a technical term known as oral submucosal fibrosis. So sometimes these are form of small lumps inside the mouth. Sometimes even you cannot detect it by naked eye. It's a small patch somewhere, and over a period of time, if undetected and if unaddressed, it can get converted to a oral cancer, squamous cell carcinoma, by biological mechanism which is known as epithelial cell to mesenchymal cell transformation. Now these patients are typically from underserved locations. They do not have access to any kind of quality screening, and whenever these things are detected, mostly it is not only in the cancer stage but in the late stage. And then when they are brought into these high-end centers, that is too late. Either they lose their voice, or maybe the shape of the mouth because of very, I would say, aggressive surgery. Sometimes they lose their lives because these cancers may spread around the body. In the process, the entire family may shatter because the only income in generating person may have got affected. So what we did is we invented a small torch-like thing, which you can put for 30 seconds inside the mouth, and again, by machine learning based data analytics, we could come up with a classification where in a small app, within a few minutes, the recommendation will come No, it is a screening test, not a confirmatory test. Now, confirmatory test for cancer is biopsy. But it can give you a recommendation that there is a high chance of pre-cancer, cancer, or normal means anything other than pre-cancer cancer. For example, somebody is having some temporary fungal infection. That is not cancer or pre-cancer. One should not worry about that. Okay, it will easily go away. So that classification we can provide to a rural healthcare practitioner. And then that person can decide on the follow-up. So in that way, the mission, as I have given this as an example, but in the blood test, infectious disease test, whatever, the objective is to bring the high-end technologies to the ambit of the common people, where it can be disseminated outside control lab at extreme resource limited settings, at low cost, and by frontline health workers.
Yes.
We don't require a sophistication in any. And this is what is our technology enabled solution for rural healthcare. So making the high-end technologies which were otherwise not accessible to them, to make them available in a timely fashion at low cost to them, so that it can create a decisive change, saving lives, and in the process creating rural livelihood by creating rural jobs, self-sustainability of health workers and MSMEs. And this is what I say, that technology enabled holistic approach to look into rural health.
Yes, that is the actual purpose of technology, Professor Suman, and wonderfully explained. Professor, I have come to an end of this wonderful session, but before I end, I want your views and your opinion on the recent research domains on which the viewers on my channel, if they must be listening to you, so in which directions they can pursue their research. What are the recent domains of research which you will suggest them?
Yeah, again a very important question, because when we were young students, we also got confused, because in every era certain buzzwords come.
Yes.
Like now you have AI, ML, and students will think, so you go to a school student, the school student will think that Python coding is the first and last thing in life. Okay. Now one has to understand that Python coding is very important. AI, ML is very important, but one has to look into the problem that is being solved.
They are techniques.
Rather than just taking it as a piecemeal, whether it is coding or AI or ML or whatever. So I would imagine that we should look into the grand challenge problems. What are the challenges that the humanity is currently facing now? Global warming, climate change, healthcare crisis, sustainable and green energy technologies. In that way, say clean water and environment, which has very little pollution, but it is technologically advanced, because these are a bit conflicting.
Right.
So now we have to look into it from the viewpoint of, rather than what is my area, rather than what is the problem that I want to solve.
Yes.
Now all these problems will require basic science, different aspects of technology, including AI, ML, data science maybe, and maybe beyond, like humanities, social science, economics, what and what not. So I would imagine that instead of being sort of carried away by buzzwords, what people are saying, what you need to get jobs, why don't we see the far vision, so that we think that I want to solve a problem for the humanity. And for solving that problem, this is the core strength that I want to develop.
Right.
Be it engineering, core engineering, like something like mechanical, electrical, I would say golden engineering, core engineering, which will remain forever, or civil maybe, soft form of engineering like maybe computer science, data sciences, be it humanities, social science, whatever. But instead of so first of all we have a vision, what is the problem that we want to solve. Second is we need to identify a core domain from which we want to diversify. Let us not be interdisciplinary researchers to begin with. because then we will all be jack of all trades and master of nothing.
Right.
Interdisciplinary research doesn't mean that you are one of the spices, you need a little bit, but nobody knows how to cook the food. So you require to be extremely strong in one of your core domains, and you should have an open mind to learn others and to work out towards a solution to a problem, rather than going against buzzwords.
Very true.
And then whatever is your passion, get directed, and not what anybody is saying about maybe coding or AI or there is life beyond that, and there is a lot of physical hardware that one has to learn and do to make something useful and effective for everyone.
Wonderfully explained, Professor Suman. So the real purpose of any research or technology is to solve the real world problem, and you are the epitome of that. You have displayed that through your inventions. All your inventions have at one point or the other tried to solve the real problem of the humanity. And all these buzzwords which you mentioned are the tools and techniques. Yes, they are to be learned to solve this. So wonderfully said, Professor Suman. And I come to an end of this wonderful session. Professor Suman, it is almost 2 hours I'm engaging you now for. And my job was very simple. My job was to ask you. And your job was really difficult. You explained with the same vigor, with the same energy. And I'm happy, sir. I had this more than 15 points of discussion. And for a person like you who has so many invention and research domains and so much of work done, summarizing everything in 2 hours was really challenging. And I also understand that there are so many other things which I could not ask you and within this short span. But 2 hours, it passed by, and I really enjoyed entire interaction. And I'm very sure students who will be listening to you and this interaction, they will also learn many things from this particular interaction. So let me thank you from the core of my heart, Professor Suman, for giving 2 hours from your busy schedule to me for this interaction. And I wish you all the very best for your future endeavors.
Thank you very much, and it was really great. And as I told you earlier, also nothing of this discussion was sort of rehearsed or prepared. We just entered into discussions and dialogues, and I will be very happy. I have a sort of, I would say, a philosophy or a mission about how should we approach maybe science or research,
yes,
or overall academics as a whole.
Right.
So I would be extremely happy if I find that this interests broad student community, and of course more happy if I can sort of trigger or kindle the interest of the next generation people, which is one of the responsibilities of me as a teacher.
Yes.
Thank you very much for giving me this platform.
Thank you, Professor.